All right, workshop students, let me try another one. Looks like this is number 2 here from this week's quiz. And let's talk a little bit about this one. And if you saw my first video for this quiz, you remember there was a discussion here about the torque. And the torque is R cross F. And in order to have a torque then, you have to have some distance and you have to have a force. And of course then, the cross product means some sine of the angle between them. So the magnitude of the torque is RF times the sine of the angle between the R and the F. But the big thing is to keep in mind that torque is more than force. Torque has a force, but it also has a distance and an angle involved. And so these are more complicated problems here. Now, if I read this one correctly here, it says a metal rod with a mass of, and so they give us a mass, they give us its length, and it leans against a wall. All right, so maybe I'll do something like this, and it's leaning against the wall. And so here will be the wall, it'll be the floor. I'll make a little dotted line for the vertical, because it goes on to say the rod is angled 20 degrees from the vertical. And I'm glad they give this part. See, this part says the origin is the point where the rod touches the floor. So you can't calculate a torque unless you also are saying torque about what point. That was our discussion in this last video, where we can talk about a torque as measured from the center of the ball or the torque as measured from the surface of the table between the, which would be kind of the rim of the ball. And so that's that important piece here. And so for us to match their answer, we have to have the same origin. So we got to make sure that we're picking the same origin that they are in what the answer they're expecting. So that phrase is crucially important here. The origin is the point where the rod touches the floor. All right, so put that little dot there. It says the magnitude of the torque exerted on the rod around this origin by the force of gravity. All right, so then they want the force of gravity. So one thing we're going to have to add to this picture here of our rod is that there is the center of mass. And the rod, I'm going to assume, it doesn't explicitly say, but the rod is a uniform length. And so this is the center of mass. So when I go to calculate the magnitude of the torque, RF, and the sine of the angle between them, the R would be half the length of the rod. The force of it would be its weight, mg, and the angle would be between the R and the F, and that is also 20 degrees. So putting in my numbers here, the length is 1.13 divided by 2. The mass is 2.41 times 9.8, then the sine of 20 degrees. So if I get out my calculator here, and let me just check that I'm in degrees. Okay, good, I am. I can then go 1.13 divided by 2, then multiplied by 2.41, and then multiplied by 9.8, and then finally the sine of 20 degrees. And so 4.56, and remember length is in meters, and then weight is in newtons, so this would be Newton meters. So sure enough, 4.56 Newton meters. All right, hope that helps somebody.